Cool. Right. Cool. Everyone's muted. Okay, so today we're going to be doing a little bit of computing, and we're going to be looking at some how to build an online circuit later in the session. But to begin with, we're going to have a look at what it means to stay safe online. So there's lots of fun and interesting things you can do on the internet, as I'm sure you know, whilst we've been on lockdown. And it's a good way to stay in touch with your friends, like most of us have been doing, but it is really important that we understand how to stay safe online. Sometimes there's some people that will try to trick you into clicking dangerous things or sharing things about yourself, or something you share might be used to bully or frighten you. So it's important that we know how to keep ourselves safe online. So, some top tips to stay safe. So, think before you post. If you think about posting something anywhere and you think, I wouldn't like my mum or dad to see this, then maybe you shouldn't be putting it online or wherever you're posting it. So, always have a think about that first. And remember that once you put something online, someone can take a picture of it or screenshot it, and then that's it. They've got it forever and you've lost control of it. So, always make sure you have a good think about what you're putting online before you put it out there. Never ever share your personal details online with someone that you don't know or someone you've just met. That includes things like your address, your phone number, the name of your school, the name of your friends, anything like that. So never share any personal details online. Watch out for phishing and scams. So phishing and scams is basically when someone tries to trick you to get information out of you. They might use big clever words that you might not understand. Usually it's things like your passwords. So remember, if you're a little bit confused and you think, well, why is this person asking me for this? Don't give them any information, and check with an adult to see if it is legit. Think about who you're talking to. So there's lots of people you can meet online. Some of them will be nice, some of them are not so nice, and they might try and trick you to do something that's not very trustworthy. So never trust someone you've met online unless you know who they are. Keep your device secure, so get your mums or dads or grannies or granddads or whoever it is to make sure that whatever you're using online is nice and secure, and you can't click on anything that might be a little bit naughty. And never ever give out your password. That's the number one rule. So if anybody ever asks you for your password, you should never ever give it to them. And you should always choose passwords that are nice and strong, so a bit difficult for someone else to work out, but easy for you to understand. And if you do have to write your password down somewhere, make sure you keep it somewhere safe where someone else won't be able to find it. So if you've done all that and you still think you need a bit of help because something's gone wrong, speak to an adult you trust. That could be your parents, your grandparents, someone that looks after you, or a teacher at school. So make sure you always speak to an adult you trust. You can report the abuse or the bullying or whatever's happened to the website or the app you're using. They always have an option to report a problem. Delete anything you have shared as soon as you think something's wrong to try and make sure you can get on top of it. You can tell the police if you want. You can either ask your parents and they might tell the police, or if you think you need to do it straight away, then you can, but that should only be done when it's very, very serious, and it's good to check with an adult first before you ring the police. And plan for the future. So if something has happened, change your passwords and your privacy settings so that it doesn't happen again. Or if you don't feel comfortable speaking to an adult, you can always ring Childline if you don't feel comfortable speaking to anybody else. It's free to ring Childline. It costs absolutely no money. But again, you should only ring them if you feel like you're in a really sticky situation and you've got no one else to talk to. And a good way to remember their telephone number is to go 08001111. So it's 08001111, or you can go to their website. So if you don't have a trusted adult, or you don't think you can tell a trusted adult, you could always speak to Childline. But again, that should only be done if you think something serious is happening. So that was our whistle-stop tour of how to stay safe online. This will be on YouTube, so you can go back and have a look again if you feel like you're still not sure, or you want some more tips on how to stay safe. So we're going to be going on to our making circuits. So hopefully you've all got an iPad or a tablet or another computer or something you can use. And the link, I sent it to some of your emails last night. and also you might be able to get it if you just look on the screen. You'll be able to type it in off the screen. When you go onto it, don't do anything, just have a look at the screen and I'll show you what we're going to be doing. So yeah, just click on the link or get the link up on your iPad and then show me on the screen once you're there. If you've managed to get on, you give me a thumbs up because I can't hear you at the moment. So if you're on, you can give me a thumbs up. Well done, Felix. I'll just give Finley, Izzy and Polly a little bit more time. Are you on yet, Finley? No. If you could unmute yourself and then, yeah, we can have a chat. Is it not working?
It's not come on yet. It seems to be.
Ours isn't working either.
Okay.
Saying it's could not be found.
Right. Hold on. Let me click on the link and see if it works for me. 1 sec. I'll just sort the screen out.
Why is it not working?
Try that again.
I don't see what. There's.
So when you go on, you should get this screen.
Yeah, if you type it in yourself, it doesn't seem to work. But if it's directly from Nathan's email, it worked for us.
No, yeah, ours isn't working.
So
We're getting this.
Yeah, and then if you click play,
Yeah.
it should take you to this screen.
Let's see.
Start again. Right.
Yeah. Oh, yeah. Okay.
Cool. Right, and then you can just wait there. And then, did you say it was John?
Yeah.
Yeah. Have you got an email link for it or not?
No, Deb just sent me the link through WhatsApp.
Right. Okay. And when you click on it, what does it come up with?
Well, he didn't have WhatsApp on his iPad, but we couldn't actually get the same WhatsApp. It's a different one.
Right.
But it's got the message here because then I forwarded the message to Finn's iPad.
Yeah.
The link, sorry. But it's come up with this. I don't know if you can see it. That's the link. So if I click on that,
yeah,
and it should come up, shouldn't it?
It should do, yeah.
Right.
It's turned off, Mum.
Yeah, it seems to be loading quicker now. That's it.
Yeah. Right. Cool. Okay. So if everyone can see my screen, this should be the screen you're all on. If you want to mute yourselves again, and then you'll be able to hear me speak.
Right, mute it, Anthony, and then we'll.
How?
How did you do it before? No.
There you go. Brilliant. Well done, Finley. Cool. Okay, so took a little bit to get here, but that's okay. We're here now. So everyone should be on this screen. And what we're going to do, I'll walk you through how we're going to do it. And you're going to listen to me first, and then you can copy. But to begin with, don't click on anything unless I tell you to do so. So to begin with, you can click intro, and it should take you to this screen. Once you're on this screen, just give me a thumbs up so I know we're all here. Brilliant. We'll just wait for Felix. Are you on this screen, Felix? Give me a thumbs up if you are. Cool. Okay, so down the side, we have our different components for our circuit. So you can see we've got wire, battery, light bulb, resistor, switch. And then if you go down, we've got a couple of other things. The ones we're going to be using today are the ones on the first page. And if you go to the second page, we've got paperclip. Other than that, we won't be using anything else. And to begin with, for about 30 seconds, I'd like you to just, or maybe a minute, just have a little mess around. You can drag the things out from the screen and you can place them around on the screen and they can do different things. So just for a minute, just have a play around at putting things on the screen and then I'll get you back together. Morning, Nina. Morning, Monica.
Hi.
Hi, okay. Have you got the link to this website anywhere?
What is it called?
It is called, one second, let me just move.
Mhm.
So if you type in,
Yeah.
hold on a minute, PHET
PHET. Yeah.
.Colorado, which is
COLORA.
COLORADO
Dear.
.edu
EDU.
forward
Yeah.
slash
Sorry.
forward slash. Do you know what that one looks like?
Is it that one?
It's like the little line that's sort of leaning toward, like leaning away from all the other words.
Yeah.
Yep. And then SIMS, which is SIMS.
SIMS. Yeah.
And then another one of those forward slashes, so another leaning line.
Yeah.
HTML.
HTML.
And then another forward slash.
Yeah.
And then circuit, which is SIR. No,
Mhm.
CIR.
Yeah.
CUIT.
Wait. Now I've got confused.
CIR.
CIR. Yeah.
CUIT.
CUIT. C-U-R-A-T.
Just IT. C-U-I-T.
I-T. Yeah.
And then a dash, which is just a little line. It's not like, it's just, yeah, just a straight line. And then construction. Do you know how to spell that?
Yeah. Yep.
And then another dash.
Yeah.
Kit.
Kit.
And then another dash. DC.
DC. Okay.
Click search and it should come up with a screen, hopefully.
No. It says not found.
Okay, just type in FET Colorado instead then. So P-H-E-T
P-H-E-T.
dot
Yeah.
Colorado, C-O-L
C-O-L. Yeah.
O-R-A-D-O. And then search for that.
I've got this screen.
Right, bear with. Then if you go on the top one, which is
Yeah.
FET University, and then go to can you see the search option on that page?
Yeah.
And then type in circuit.
Uh-huh.
And then the second one down says circuit construction kit.
Mm-hmm.
Click on that one.
Nope, wrong one. Yeah. I did the wrong one.
That's okay.
Circuit construction kit. Okay.
And then does it have a play button? No, yours says download. 1 second, everybody else. Technical difficulties. Right. Okay, if you go to, if you type circuit again,
Yeah.
and then go to, see the second one up from the bottom, circuit construction kit DC virtual lab.
Yeah.
Click on that one and then click play.
Yeah.
And then it should take you to this screen.
Yep. Got it.
Right. Brilliant. Okay, you can mute yourself now, Nina, if you want, and then we can carry on. Cool. Okay. Right. Sorry about that, guys. Welcome back. Just a few technical difficulties that we had to sort out, but we're there now. So I hope you've had a good little play around, and you know sort of what the main functions of this are. First of all, 10 seconds. What is a circuit? So talk to somebody next to you. Have a think in your head. What is a circuit? Okay, time's up. If you think you know or you have an idea, you can unmute yourself and we can have a little discussion about it. Okay, Nina, off you go. What do you think a circuit is then?
Is a circuit like something that powers everything?
Yeah, so circuits are
No.
used to power different things. It's a good idea, Nina. Izzy or Polly, have you got any ideas?
I think a circuit is a bunch of materials that make something work.
Yeah, okay, so a little bit like Nina's one. So something that maybe makes something else work. Finley or Felix, you got any ideas? It doesn't matter if you haven't, that's okay. You have to unmute yourself if you'd like to say anything. If not, that's fine. No, brilliant. Okay, so Izzy and Polly, if you want to mute yourself again. Yeah, so a circuit is a little bit like what Nina and Izzy said, which is something that makes something work, but more specifically, it conducts electricity. So electricity flows around a circuit and makes something work. So in order to have a circuit, you must have something that produces electricity. And in this case, we're using a battery. So the battery powers our circuit, which allows a flow of electricity to power, in our case, a light bulb. And yeah, so Izzy and Nina were right that circuits are used everywhere to make something else work. So there's circuits in our television to turn the telly on. There are circuits in the walls to turn the lights on. There are circuits in the oven to make the oven work. So everything uses some sort of circuit to allow it to be powered on. So anything that uses power must use some kind of circuit. Now, I'm going to set you a little challenge. But first of all, we're going to run through what these different things are. So we have a wire. Now, a wire is what conducts the electricity and lets it flow round. And it's insulated, usually with rubber, so we can't electrocute ourselves. Now, our battery is usually made up of some sort of chemical inside, which produces electricity through chemical reactions. We have our light bulb. I'm sure we all know what a light bulb is. And then we have a switch. So we can have an open switch or a closed switch. And switches allow us to turn on and off different circuits and different things. So when you switch on a light switch, you switch on the circuit, which powers the lights. And when you switch it off, you switch off the circuit, which then switches off the lights. Now, to begin with, I'd like you to use 6 wires. So you can drag 6 wires out, if everyone could do that for me. And you need 1 battery. So 6 wires, 1 battery. A light bulb. And a switch. So that's everything on the first page. 6 wires, 1 battery, a light bulb, and a switch. We don't need a resistor yet. You can leave the resistor where it is. So what I'd like you to do is I'd like you to try and create a circuit that powers on the light bulb by connecting all these things together. It doesn't matter if you get it wrong, because I'm going to show you how to do it anyway, but I'd like you to create a working circuit using just those things. So I'll give you a couple of minutes to have a go at trying to make a circuit that powers the light bulb. Off you go. Okay, your time is up. If you could, doesn't matter if you finished, it's okay. If you've not finished, that's fine. If you could hold up your circuits to the camera so I can see what you've done so far. Brilliant. So has everyone got their light bulb on? Give me a thumbs up if you have, because it's difficult to see on some of yours. I think I can see Izzy and Polly's has got their light bulb on, and Felix has got his on. Brilliant. And Finley has. Oh, okay. Nina's is not on. Okay, so brilliant. Well done if you managed to get your light bulb on. I'm going to show you how a proper circuit should look. So our circuit should always run parallel. Now, parallel means that they always run in the same direction, so always in straight lines generally. So I'm going to start with the switch, and I'm going to attach the switch to the first wire. I'm going to leave it open, so not on, until I'm ready to show you how it should work. I then attach my battery, and I connect the next wire. I then put my light bulb over here. I attach my next wire up here, bring that one down, attach to the next wire, finally to this one, put another one in there. So our circuit should look something like this. So it should always be neat, straight lines, and always run in parallels or squares or rectangles or something like that. And when I switch this on, what should happen is the light will either come on or something else might happen. We'll just have to see. Brilliant. Okay, so the light has come on, the bulb has come on. What some of you might have done is, if you do it like this, you can see that because I've switched the resistance off in the light bulb down here, it has no resistance to the electrical current. And what happens is the battery sets on fire and the current is going too fast, so it overcharges the battery. All of our light bulbs come with a little bit of resistance in so that it can withstand, it can take that electrical current. So if I add just a little bit on, you can see that it's not enough. Add a bit more, there you go. So all it takes is one, I'm not sure what that is, I think they're called ohms, 1 ohm of resistance for the battery to be able to power the light bulb. Now, the more resistance I have, the dimmer the light will be, and the slower the electrical current moves around, which basically means that the light bulb uses up more of the energy that flows around the circuit. So have a go now at putting your circuit back together how I have. So you can refresh the screen, and then I'd like you to make your circuit exactly the same as mine with 15 resistance on your light bulb. Once you've done that, you can hold that up to the screen to let me have a look. So again, you should be able to do it with only 6 wires, 1 battery, a switch and a light bulb. You shouldn't need any more than that. Brilliant, well done, Felix. Superb, we'll just wait for the other people. Well done, Nina. Good girl. So you got there in the end. Well done. How you getting on, Izzy? Okay, while you carry on doing that, I'm just conscious that we're going to run out of time because I only get 40 minutes per lesson, and then it will kick us all out. So I'm going to show you the next bit. And what I'd like to do is just sort of have a look whilst also making your new circuit. The only things that conduct electricity are things that are made of metal. And now I've dragged a paperclip out because paperclips are made of metal. Now, if you put this paperclip anywhere in the circuit, and if you put it in a real circuit, the circuit would still work because it can conduct electricity. So if I attach it here and switch it on, the circuit still works because it conducts electricity. If I take it out of there, join that back up, and I put it in between the switch and the first wire and close the switch, it will still work. So you can attach the paperclip anywhere in your circuit and it will still conduct electricity because it is metal, and metal conducts electricity. Now, you should notice that all the time our energy flows the same way. It never changes direction and it never goes that way and then goes back that way. It always flows the same way. And that's the same in any circuit. And also, we never use up any of the energy. It just gets turned into something else. So in our light bulb, it gets turned into heat. If you leave a light on for too long, it becomes really hot if you touch it. So our energy from the battery turns into heat. And then that eventually turns into something else, which turns into something else. So energy is never used up. It's just turned into something else. One quick thing I will show you is rubber. So rubber is not made of metal. And as I just said, the only things that can conduct electricity are metal. So if we add the rubber in, the circuit stops working because the rubber is an insulator. So it stops the electricity. So it flows around and it hits that rubber and it can't go anywhere. So it doesn't work. But if we add the paperclip back in, the circuit works again. The other thing you can do as well is to increase the voltage on our battery, which will also make the bulb brighter. So unfortunately, we are about to run out of time, so I'm going to have to really cut this short now. But you can keep playing around on that website, keep having a look, try some of the other different things, and I will send you all a message to see how you're getting on. But other than that, I hope you've enjoyed it. It was a really quick whistle-stop tour. And keep playing around on the website, keep having a look at some of the other things. But other than that, I'm going to have to jump back onto here. You can all unmute yourself if you want, and we can say bye because the meeting is about to kick us all out. So keep having a play at that website. I'll put some more websites up and stuff like that. So yeah, well done, guys. Thank you very much.
Bye.
Bye. See you soon. Bye.
Bye.
Bye. Bye. Bye.
Thank you.
Thank you.
Thank you. Bye bye.